Hello, everyone. Thank you for joining me today. Today I will be talking about how to trigger event-based jobs, specifically in Google Cloud. We're gonna do a little bit of small history lesson. Then we're gonna talk about how are we currently running these on the cloud, and after that we're going to do a small demo that I had working since yesterday, so I sure hope it works today as well. So quickly before I get started and running, who am I? Short introduction. My name is Ruben Blazquez. I am originally from Spain, but right now located in the Nordics. I am the CTO and infrastructure and app modernization lead for Devoteam G Cloud, who is a Google Cloud partner working on implementing solutions all around Google Cloud solutions. I'm also been working for with Google Cloud Technologies for almost 6 years now, and therefore I've done a lot. I've seen a lot. So if after this you have any questions or you want to chat about the content of um, of this presentation or anything like that, please feel free to reach out to me. I'll be more than happy to talk about it. So, without any further ado, let's talk about how we're running jobs. So, I have a very terrifying AI generated image of Steve Jobs running here, just to kick this off. But um, let's talk about it. So. Now, running jobs. Many people know jobs and chronological workloads, if you want to call it like that, as your typical. Um, I have a server running somewhere in the back of my closet, that or a laptop, not even a server, not even a VM, just a laptop or something that has it configured with a cron job or something like that. That every hour, once a day, once a week, whatever, that it is going to execute whatever script you have told it already to do. Now, usually the way we've done this has been for very simple workloads and very, very simple use cases. But in some cases, you actually see it happen in a more complicated fashion. But that comes with some issues. Some of them are specific to running jobs, but most of it is specific to running things on a single server in the back of your closet. So, of course, you got issues such as single point of failure. If your server, VM, whatever you have, um, was to fail, power off, whatever, that will be a problem. And we would not be happy about it. It's of course not highly available. That means if anything happens or if you need to migrate from one site to another, you're usually not prepared for that. And it is definitely not scalable and always on. Now, scalability, in the sense that we talk about many times, it's more about scaling up, but we also have to talk about scaling down, of course, because you don't want to scale up to having 10 instances, 20 instances, 30 instances running your workloads that then never go down once you are done. And always on is a problem in two senses. One, it's a problem because you're just wasting compute power, and that's costly, whether it's by your power bill or if you're running this in a virtual machine in the cloud, you're just paying for um, compute time that you're not using, which is a waste. But also on the sustainability part, it's not that sustainable to have things running 24/7 if it's only gonna actually execute something 2 hours a week, 2 hours a day, or whatever. So now we're starting to get modernized a little bit by going into the cloud, by using serverless solutions and more. And that's when we have other options. Now here I have put the icons of a few solutions. I will be talking a little bit about a few of them, and then the demo I will do will be specifically in Kubernetes, because this is the case that I have seen um, come up more often with the needs of customers and just people running their workloads in the cloud. So now, once you move into the cloud or even go to serverless, and start running your jobs in a more dynamic and scalable way, you start getting a lot of benefits. One of them is auto scaling, of course, and being able to downscale all the way down to zero. If you have workloads and jobs that need to run that are not your typical, I don't know, I need to clean up a database once at 2 a.m. every day. But it's more like certain things happen, then I need to ingest a bunch of data, or I need to analyze things based on events, which is the demo that we're going to do. Um, then sometimes you might have it be 10 times more intensive, or sometimes you might have a 50% less workload than usual. So you want it to be able to scale up and down and be right sized all the way. Now, of course, scaling all the way down specifically to zero will be a lot easier if we do serverless, but whatever and however we do it, you have the typical advantages such as being regional, highly available, right sizing, having it be sustainable based on right sizing, and also being able to downscale all the way down to zero. And therefore, we have many ways to ensure that if our job doesn't run properly or that it fails, that it retries, and if, I don't know, Frankfurt is down, that you run it in Helsinki, for example. So um, those are some of the benefits. So again, before I go into talking about Kubernetes specifically, I wanted to give a couple honorable mentions, let's call it, to some of the services where we can run jobs in a dynamic way based on events. Again, these are not all, but I wanted to highlight the fact that there's no one size fits all. There's not the one solution to rule them all. You can always do these things in many, many different ways. Um, and of course, you can always just run it on a virtual machine that has such a complicated and convoluted script that it knows how to turn itself off and on and just be decent. But this, we want to do it also with a minimal amount of development time. So we don't want to get caught up in having to maintain something that suddenly it's cumbersome to maintain, that it adds operational overhead if it doesn't work. We ideally want to work with managed products and a managed way to receive those events and ingest them. So I will be out of these three, I will be focusing slightly more in cloud workflows, just because I think it's pretty cool, but not that well known. But we also have Cloud Functions and Cloud Run. For those of you who don't know, Cloud Functions is just a simple serverless way to run a function. So you just give it a piece of code um, and a few different runtimes that it supports, and it will just execute, and that can be triggered for many things like pub subtopics, events such as you uploaded something into a bucket, you made some changes to um, service in Google Cloud. Many ways, there's hundreds of different triggers by default that you can use to go into Cloud Functions. And then Cloud Run, that you might be familiar with, it's a way to serverlessly run containers. So if you don't have any specific dependencies that you need to run Kubernetes, or you need to be in a specific node pool or anything like that, then your best bet is probably to run in Cloud Run if what you have is a container. Um, so now going into workflows a little bit. Now, what is Google Cloud Workflows exactly? It's just, again, another serverless solution to orchestrate workflows. One of the things that I like the most about this is that it has a maximum timeout of 365 days. Therefore, you can run a workflow for a very, very, very long time. So the workflows, the way it looks like, it's a set of one or many different steps. And in this case, it's tightly integrated with many Google services that allows us to um, it allows us to integrate into those services, call different services, and based on different events and occurrences, do one thing or another, or if it fails, just fail, stop, alert, and continue somewhere else. So now the workflows, like I said, is a series of steps. And this is the different kinds of steps that you can have when it comes to a workflow from the start to end. You assign, you call, you switch based on conditions, and you can race, or you can then do more calls, then get something in return, and finalize the workflow. In a second here, I'm going to show my console with a very simple default workflow, actually, just to show how easy it is to configure. At the end of the day, it's just a set of YAML steps. You just define it in YAML, and it's a bunch of calls, and it's either to Google Cloud services, or it's like HTTP calls that just calls one service to another, and then it can, wait for approval, wait for something to work, wait for something to break, whatever it is. Well, one of the reasons why I really like workflows, first of all, it's because, again, it's really, really simple. And workflows, actually, if we go back to here, workflows can trigger a cloud function and can trigger a cloud run. So workflows is not necessarily a replacement for, if instead of using cloud functions, use workflows, instead of using cloud run, use workflows. But if you have a multi-step workflow, part of a job, let's say, you've uploaded a bunch of invoices. Therefore, once that gets uploaded, that triggers the workflow. Once the invoices are uploaded and approved or whatever, then suddenly that goes into another step that actually analyzes the content of the invoices. And once that is done, then that goes through someone that manually has to review and approve. And if that is fine, then it gets uploaded into the final step. Now, this is why I like workflows. It's because many workflows and many steps, specifically if they're business processes, actually have to come through a manual step at some point. So therefore, Cloud Run has a new service that is Cloud Run Jobs. So it's specifically for running jobs. Now the problem is that has a timeout of 60 minutes. Now a workflow, if you want to make sure that something from beginning to end is done, but in the middle there's a step that maybe takes 2-3 weeks to complete, you don't have to worry about that. So that's a very nice option to have that running, and then it can make sure, instead of you having, for example, a set of 1, 2, 3 Cloud Run services that you just hope, or you have to put a bunch of logic in between those services, that instead of doing service-to-service communication between different Cloud Run instances, you can just have a workflow set orchestrating all of those different steps to make sure that from the beginning to end, everything ran properly, and therefore it's a single source of truth that has the entire context of the workflow itself. Now, going back to this, triggering workflows is very simple and can be triggered many different ways. So let me quickly show in the console now a little bit. But as you can see here, it's this is what the definition of a workflow looks like. It's very simple. You just have steps, you have calls, you have switches. You can identify your type, your audience, put a URL, whatever, but it's not very complicated. And then that is attached to a Google Cloud service account, and that will make you be able to invoke different services like Cloud Run and already be authenticated without you having to put in a bunch of code on how to authenticate yourself, how to be allowed to do certain things. So it makes it really easy, and just by having this small piece of code, you don't have to worry about making your own container, updating it, make sure that it's secure, make sure that it's up to date. You just have 10 lines of YAML code that is in charge of making sure you call your Cloud Run service, which is very much welcomed. So now if I quickly jump here into the console so that you can get a very quick look on how a workflow looks like. Now, okay, there we go. So I have a very, very simple workflow here. And by very simple, I mean it's literally the default when you go and create a workflow. Google already gives you one by default. So if you look at the definition of the workflow, I'll actually, instead of creating one, I'll just show you. It gives you an already predefined workflow, which also gives you a visualization of what it looks like. So in this case, you have the start, which then it checks the search input, and then depending on, it does one thing or another. It gets your location. Based on your location, it does a call to Wikipedia. So basically it gets like, okay, you're in Europe. Then knowing that I'm in Europe, then with that information and that existing context, it will return to me, I think like 5 or what is it? I'm not sure. There's like, it returns to me a few um, Wikipedia articles related to Europe. So now what I've done, talking about triggering from events, now this has many, many options to do so. So I want to showcase it really quick by editing here. So when I go to add a trigger, I can do two things, either a cloud scheduler, which it's basically a cron job that calls whatever other services. So you can just tell it, okay, this workflow I want it to run every 2 hours. Then it can just do that, as simple as that. Or if you do want it based on an event rather than amount of time, you can then do event arc. And if you've not seen this before, you will see that there is a lot of different options. So you got trigger types, which is either Google sources or a third party. In this case, I only have Datadog in here. But if we go to Google sources, I'm not going to go through all, but as you can see, it's basically almost every Google Cloud service you can think of. Will allow you to trigger this workflow. So for example, we can go into cloud storage and then search of an event based on cloud storage. So once I wanted to trigger, once an item has been archived, once something has been deleted, once something has been finalized and uploaded, once the metadata has been updated, right? These are direct triggers. And then you also have some that are based on the logs. So whenever you create a bucket, whenever you delete a bucket, whenever somebody lists all the objects, so anything. The world is your pickle. You can choose whatever you want. And then all you have to do is choose which service account is going to be executing that. So of course, if you want to follow best practices and you don't want to do bad, you are going to want to do this with not the default service account, and make sure that it has the least principal, uh, the least privilege access as possible, so that you don't run into issues. And of course, once you select whatever you want, you can have it show the command line equivalent. But long story short, I have set this up with a pub/sub event. So whenever I send a message to pub/sub, then it executes. And as you can see, I've done quite a lot. So then if I go to any specific executions, and I go here, the input is this, the output is that. So we get Europe, European Union, European Parliament, and European Commission, all these different things. Now, if I were to be from the United States or any other location, then my output would be different, of course. So now this is calling an endpoint of the Wikipedia API, but this could very well just be Cloud Run container, could be Kubernetes, it could be anything I have on premise, it doesn't matter. And that's the beauty of it. So, and again, it is just as simple as a few steps put in here. You don't have to maintain a container, you don't have to maintain anything. and it will ensure that the entire process has been up and running. So that's what I wanted to talk about when it comes to workflow. So the 10 minutes or so that I have left, let's use it to talk about how to do this in Kubernetes, which is probably the most common use case when it comes to how do I run this if I don't want to code my own solution, which is a totally valid option, of course. So now, we're talking about doing it in Kubernetes. DIY Kubernetes is super hard. It's complicated. It has a bunch of operational overhead. And then you are responsible for all of those things that aren't in blue. So monitoring, scaling, availability, patching and upgrades, security, networking, configuration, control plane provisioning, all of those things, many, many things. Now, if you go into a managed Kubernetes solution, in this case, Google Kubernetes Engine, also known as GKE, suddenly the blue part becomes a lot bigger just by using the standard mode, and you only have to manage the worker nodes, provisioning and management, and the security networking configuration. And now Google has recently come out with Autopilot, which is now the new mode of operation that takes care of basically everything, the auto scaling, just absolutely everything. You just need to worry about your pod. What do I do with my pod? Where do I put my pod? That is all you need to do, which makes it so that you're always super right sized. Which, if you don't have it configured the best by default, your Kubernetes, it's going to save you a lot of money. And it's also going to be more sustainable because you don't have a bunch of workloads, not workloads, sorry, nodes running in the cloud for no reason. So really quickly about scalability, this is what the 4 dimensions of scalability looks like in Kubernetes. You have horizontal pod autoscaler, so more needs more pods, or vertical, more needs bigger pod. And then you have the cluster autoscaler and the node auto provisioning. So if you go into Autopilot, which is actually what I'm running my demo on, Autopilot takes care of the whole bottom part for you. So you don't need to worry about auto scaling your cluster. You don't need to worry about auto provisioning. So this is like the best, most efficient way to run your jobs and your workloads. Now, we're doing this with workload identity, which I'm not going to go super in depth, but basically, whenever you're working with Google Cloud and Kubernetes, use workload identity is the best, most secure way to connect to other services. So now, what we're going to do is I'm going to show really quickly a demo that's going to be Argo events. And Argo events is just a way to take from many multiple sources, like for example, a Kubernetes resource, a scheduled something, pops up Slack, webhooks, Git, anything, and then that goes and it creates a Kubernetes resource, for example, that runs whatever you want it to run. So in this case, what we're going to show is how a PubSub queue is, I send a message to PubSub basically, and that's just going to create a job that's going to run. So without any further ado, let's do the demo. So I need to, well, first I'll present what I have here in Kubernetes, and then I will showcase my VS Code. So long story short, I have installed Argo events. Very simple. You can just do it either kubectl and put the YAML that is provided, or there is Helm templates available and a few other ways to do it. But all you need to know, very simple to to install. So we have a few things that get installed by default just to be able to have Argo events running, and these are the 2 things that we have installed, which is the event source and the sensor. So let me now quickly share my VS Code so that you can see the YAML spec. Okay, there we go. So we have three things. We don't count the test YAML. So we have, let's start here actually. We have the event source, which is very, very simple. As you can see, it's 90% comments and 10% actual lines. So this is just an Argo resource that is an event source in this case, that all it does is I have selected it to work with this Kubernetes service account, which that's what's configured to work with workload identity to securely be able to connect to PubSub. And I'm just basically telling it what's the project ID to run on and what is the topic and subscription from PubSub that is going to take the event from. That's it. Then once you deploy that, what it does is it connects to a subscription and it's just listening to it. As soon as you send a message, it starts running. There's no more to that. And this part is actually what I'm gonna run to showcase the demo. It's not part of the YAML. It's just easier to have it there. Now, really quick, I have this specific YAML for dealing with the service account. All I'm doing is defining a service account here that is attached to a GCP service account. So therefore, anything that runs with this Kubernetes service account is attached and works with the credentials of this specific service account of Google, which means that even though you have here the email address, the identity of my service account, because I'm not giving it a JSON file with the credentials or anything like that, you cannot, even if this leaked, even if this is in the recording, whatever, you cannot access anything because you don't have any credential whatsoever. So all I've done is give it some sort of role and some sort of access to be able to just create jobs, basically. And that's it. And then I have the sensor, which this is listening for the event source. Every time the event source gets triggered, this creates a job in Kubernetes based on the whale say what do you call it? Based on the whale say Docker container. So it's very simple. Then it takes the PubSub message, the content of the message, and then with that, it just triggers the container. So in a real case scenario, instead of having this demo container, you would just have a container that actually takes the content of the JSON file you're sending over the message, and it makes something useful out of it, like data processing or whatever have you. Now, if we go and run the demo here, which is super quick, if I run this command, what it does is it takes 20 messages to PubSub with okay. I think that's fine now. So the way it looks like is it's gonna run it 20 times and it's gonna send a message to PubSub, and that is going to trigger all of these Kubernetes jobs. So if I run this here, which hopefully it works, there we go, it starts to send messages. And now if here I start watching the logs of my jobs, you will start seeing, as soon as the containers spin up, you will start seeing a bunch of little whales. As you can see there, it's popping on and off, which it's different words from the English dictionary running on and off. So instead of random whales, you would have an actual process that takes in these JSON files. So that's basically it. One of the many ways to run jobs in the cloud based from events. So thank you so much. And if you have any questions, I'll be more than happy to answer them after this. So thank you.